In this highlight video, we're going to learn about leaving groups. Leaving groups are an important component of substitution reactions as well as elimination reactions, which we will learn about in the next chapter. After watching this video, you should be able to contrast leaving groups and nucleophiles and classify different chemical species as either being good or poor leaving groups. To start, let's look at a couple of examples of substitution reactions. In this top reaction, we have hydroxide replacing the chlorine on chloroethane to give us an alcohol and chloride. In the second example, we have this sulfur analog of hydroxide. This is called thiolate. And that thiolate is replacing this iodine to give us a thiol and iodide. All right, each of these components has some type of name. The chloride and the iodide that are removed are called the leaving groups. And that's what we're going to focus on in this highlight video. The group that comes in to do the substitution, and we've learned about these before, are called the nucleophiles. All right, remember that a nucleophile needs to have a pair of electrons that it can donate to form a new bond. Nucleophiles will be the subject of another highlight video. And the other component here, in this case, this is going to be an alkyl halide, so this X group is a halide, but we could really call this the substrate. And in this case, in this chapter, these are alkyl halides. But we'll also learn about substitution reactions where X is another group. And so this is the substrate right here. And these are just the products. All right, so we're going to focus in on leaving groups. I think it is easiest to understand the role of the leaving group if we compare a substitution reaction to an acid-base reaction. So the top reaction here is just a generic substitution reaction. Notice that we have a nucleophile. That nucleophile is reacting with this alkyl halide. In this reaction, the electrons from the nucleophile could make a bond to the carbon that bears the halogen, and that halogen leaves, taking the bonding pair of electrons with it. That gives us a product, and here's our leaving group. Let's compare that process to the acid-base reaction just below. So in this case, water is going to act as our base. Its non-bonding electrons are going to bond to the proton, and the halogen will take the electrons in that bond with them to form our conjugate base. All right, so notice that this X minus in the top reaction, in the substitution reaction, is playing very much the same role as the conjugate base in the acid-base reaction. So what do we know about what it takes to have a strong a strong acid? What did we look for in determining whether something would be a strong acid? In fact, what we looked for was that it would have a weak, stable conjugate base. All right, so the same thing is going to be true for leaving groups. So good leaving groups going to be the conjugate bases of strong acids. In this slide, we have a series of possible alkyl groups bearing leaving groups. All right, in each of these cases, the group in blue would be the leaving group, and that's marked over here. Okay, so what we want to figure out is whether those leaving groups are conjugate bases of strong acids. So to get to the conjugate acid, we just add a proton, all right? And then we can look at the pKa value of that acid to see if it's a strong acid. So if we have a pKa of -7, that's a very strong acid, -9, -10, -1.7, those are all very strong acids, and so these 4 right here are very good leaving groups because they are conjugate bases of strong acids. They can hold those electrons and be very stable. As we go down the list, notice that fluoride is one of the halides, but HF is not a strong acid, so fluoride is not really a very good leaving group. And then as we go down this way, these really are going to be poor leaving groups. Notice among the good leaving groups, we have included water as a good leaving group. So we will see reactions with water as a leaving group in a little later, in a few chapters.